Okay, so last time we were talking about functions, right? And what does we discussed about definition of function. So function is a relation, so that relation function from set A to B is a relation from A to B such that for every element x in A there is unique y in B such that the pair xy is in relation R. And generally we denote function by notation symbol f, and when xy belongs to f we write it as fx is equal to y is called as value of function f at x, right? So so what we discussed last time, A, B non-empty sets, right? A and B are non-empty sets. A function f from A to B is denoted by, right? So function from A to B is denoted by this notation, and function is a relation. F is a relation from A to B. And what is the speciality of this relation? The speciality of this relation is that for relation from A to B such that for each x in A there exists unique y in B such that the pair xy is in the relation F. This is our definition we saw. Now if pair xy is in this relation F, which is a function, then we write it as y is equal to fx. Y is called as value of function at x. Okay, this is what we discussed. Now also we discussed that key identity function. So what is identity function? F from A to A. What is the definition of identity function? Do you remember definition of identity function? F of x
X equals to x.
for all x in A. So every element goes to itself, right? So every element goes to itself. For example, if my set A is 1, 2, 3, then what is identity function? 1, 2, 3. Domain is 1, 2, 3. Codomain is also 1, 2, 3. A, A. Then I will map A to A. 2 to 1 to 1, 2 to 2, 3 to 3. That means f of 1 is equal to 1, f2 is equal to 2, f3 is equal to 3. So is it a function? First of all, is it a function?
Yes, sir.
Yes, sir.
Because it is defined. It is defined at every element of A, and every element has unique corresponding value. So that means fx is equal to x for all x in A. So this is what x, image of x is x. That's it. So if we define A is equal to set of natural numbers, and if I define f of n is equal to n for all n in n, then this is identity function clearly. Also we saw that what is constant function. constant function f from a to b. So what is a constant function from set a to b?
f of x is equal to b for x belongs to a.
For fixed b in b, choose some element and fix it. If x is equal to b for each x in a, that means everything is going towards same number, right? So for example, if my set is same set 1, 2, 3, and my set b is suppose some element, what I should say here, suppose 10. What is my set here? B is set of A, B, C, D, right? And if I define f from A to B, and what I define, f of 1 is equal to A, f of 2 is equal to A, f of 3 is equal to A, right? So is it a function first of all?
Yes, sir.
Yes, sir.
It is a function because it is every element in the domain has some image and image is unique. So 1, 2, 3, A, B, C, T. So this goes to A, 2 goes to A, 3 also goes to A. So f is a function because f of x is equal to A for every x in A. So every element goes to A. It is a constant function. Or another example, if A is equal to set of natural numbers and B is set of real numbers, and if I define function from natural numbers to real numbers, fx is equal to 5, right? So is it a function?
Yes, sir.
Yes,
Right,
sir.
everything goes towards 5. Then what we have another type of function, trigonometric functions. Right, so what are trigonometric functions? So sin x, cos x, tan x, these are basic trigonometric functions, and then cosec, cot, all these are there. So, and their combinations. Trigonometric functions. Right. Now, for example, what is domain? So, what is maximum possible domain, or maximum or largest possible domain? I should say largest possible domain of. So, if I am talking about function fx is equal to sin x, right? So, what is the possible domain of sin x? That means what are the points where it is defined?
-1 to 1.
Minus 1 to 1. Isn't it defined at 2? Isn't it defined at 2?
No, sir.
Why? Sin 2 does not exist. Sin pi does not exist.
Maximum possible domain can be the set of real numbers.
Right. In R. Because this function is defined at every real number, no problem. This function is defined at every real number, no problem, right? And its values are real numbers, because you know that sin pi is 0, sin 3 pi by 2 exists, which is greater than 1. So sin 3 pi by 2 exists, which is plus 1 or minus 1, you know it. So it is defined at every real number. So if gx is equal to cos x, is it defined at every real number?
Yes, sir.
But if I have hx is equal to tan x, then what is the possible domain for tan x? Tan pi by 2. What is tan x? It is sin x upon cos x, right? And it is defined at minus pi by 2 to pi by 2, not at pi by 2 and not at minus pi by 2. So inside this range, correct? Is it clear?
Well, sir, it's not just like it is defined ahead also, right?
So you can have more intervals also. Union pi by 2 to what? 3
Maybe.
pi by 2, right?
Yes, we have to just include the odd multiples of pi by 2, right?
And so what is the maximum possible domain of tan x?
R minus 2n minus 1 pi by 2.
R minus something, right? So r minus something. So we have to exclude pi by 2 minus pi by 2. Then we have to exclude 3 pi by 2 also, because then cos is 0. So odd multiples of pi by 2, right? Am I right? Is it correct? Do you think about it? You have to just exclude multiples of pi by 2 at which odd multiples of pi by 2 at which denominator is going to become 0. So that's the problem, right? Otherwise everywhere it is well defined. Okay, so last time we saw this definition, graph of a function. Graph of a function. So if f is a function, let A, B non-empty sets. Right, so why non-empty? Because if B is empty, then for elements in A we cannot produce any image. Right, and if set is empty, the function doesn't make sense because there is nothing to define. Anyway, so if A and B are non-empty and f is a function, then do you remember what is the definition? Graph of f is the set GF, and what is it? The pairs xy such that y is value of function at x, and where is x? X is in domain. You choose x in domain, calculate value of function at point in domain, and look at the point xy, collect all such points. Collect all such points, right? Or it is equivalently x comma fx, right? Such that x is in A. So definition of graph is clear. Note that graph of f is a subset of A cross P. So do you agree with this?
Yes.
Very good. So what is a graph? Graph is a subset of A cross B. That is an important point that should be noted here, because that helps us to understand functions in some general sense. Right. Okay, so let us go to our example. So let A is equal to R, and we defined f from R to R. Fx is equal to x, identity function, right? This is identity function. So what is graph? of f. Right. So do you understand what is the graph of this?
A straight line passing through the origin.
Right. So graph of f, but because you have already um, did such kind of things, so what is the graph of function? So, but more general sense. So what is the graph? X comma y such that y is equal to fx for x in R. Right. And therefore, what is it? X comma. But what is fx? What is y? Y is x. X in R. And therefore, all those points whose both components are equal. Right. And therefore, it is clearly subset of R cross R, which is R2 plane. It is a subset of plane. And now you can sketch the graph. Right. And what are the points for which both components are equal? So if you move on x-axis, so this is your first set domain, and this is your second codomain, right? So domain, codomain, and we generally, in case of real valued functions, so in case of this, we call this as x-axis because first component, and y, this is called as a y-axis because it is a second component, y value, it is in domain. And same distance you have to move on x and y axis, so therefore it is a line passing through origin of this type, right? So this is a graph of fx is equal to x. Correct. And if you look at any point, what are the coordinates? X comma x. And if you draw perpendicular on x-axis, so this distance is x. If you draw perpendicular on y-axis, distance is y, but y is same as x distance, right?
It will be an isosceles right angle triangle.
Yes. Fine. So now note here, if what I want, if a codomain of a function f is a subset of R, then what can you say about values of function? Whatever is the codomain is codomain of function is set of or subset of real numbers, and then the values of f are real numbers, right? And hence function is called as real valued function. Right, so a function is called as real valued function. So that is for any non-empty set A, the function f from A to R is called as real valued function. So whatever set, no matter it could be set of all matrices, it could be set of all any objects, right? All animals, all trees, but we are assigning that object with real numbers, then it is a real valued function because value is a real number. A real valued function. Right, so real valued function. Moreover, if A is subset of R, then a function f from A to R is called as. So now domain is subset of R or whole set of R, no matter. So if domain is also subset of R, that means A necessarily contains real numbers, then is called as a real valued function of a real variable. Real valued function of a real variable, one real variable, right? Because so if so real variable means the points in A are real numbers, and we vary points in A, that means we vary real numbers. So it is a real valued function of real variable. Okay, so this is clear. So let fx is equal to sin x in R, right? So is it a real valued function of real variable? Is it true? These are real valued functions of real variable. Hx is equal to tan x, right? For instance, I am taking interval only minus pi by 2 to pi by 2, right? So these are all real valued functions of real variable. Now what are the graphs? You can sketch graph of sin x, and sin graph of sin x is graph of sin x is what? All of you know graph of,
Periodic function between 1 and minus 1.
right, periodic. So this is a graph of sin x. Now what is a graph of cos x? Graph of cos x is this. Is here like this. So you know graph of cos x, and graph of tan x is so minus pi by 2 to pi by 2. As x tends to pi by 2, it is tending towards infinity, and here it is minus infinity. So tan x. So what is range? Question I would like to ask is, what is range?
Close interval from minus 1 to 1.
Sin x, right? Very good. So close interval minus 1 to 1, because every element in minus 1 to 1, it has pre-image by our previous definitions. So what is range of gx is equal to cos x?
Same as sin x.
Right. Now what is range of tan x?
All real numbers.
All real numbers, right? Because it attains every value. Even your domain is very small, minus pi by 2 to pi by 2, but it will take all these elements to real numbers. So whole real numbers is a range. Fine. So now we'll see next example. So